So in this section, we're going to look at investing your money. First, we'll start off with savings plans, where most common things that you think about would be your IRAs, 401ks, your education 529 plans. How much money would you have in those kind of accounts at the end of a certain amount of time? So that's why we start off here with our savings plan formula, and then ultimately we'll end up with, talking about investing your money in specifically the stock market, and how do you read some of that and interpret it. And we'll also talk about total and annual returns. So let's start here with that savings plan formula. You can see the formula here on the top of the notes, and this is exactly how I have it written on the formula sheet. You will notice though in your book they have R over N in both cases. I went ahead and put in 12 because we'll always assume that we're going to make 12. We're going to make our payments every month. So that's the reason why I went ahead and put 12 in. But in real life though, if you wanted to use this on your own and you only wanted to contribute 4 times a year or something like that, then it'd be R over 4, for example. And then you'd have, it's placed that 12 up there, that would also be a 4. The raw formula, I should say, is in your book, where they put R over N's, and then they put N times Y standing for the number of years. And I just kept T for our years because that's what we've been using all along. All right. P just stands for the regular payment that you're going to make into your 401k, for example, or your IRA every month, okay? And then A is your final amount that would be in that account at the end of a set period of time, after 5 years, 20 years, and so on. So let's look at example 1 together, and then I'll let you try example 2. So here in example 1, it says use this savings plan formula that you see up here at the top. And I have it labeled for you as the savings plan formula on your formula sheet. So it should be, real easy to go to when you're taking your test. How much will Kim have in her IRA if she retires at age 65? Her IRA offers an interest rate of 6.25%. She started the IRA at age 25, and she's going to deposit $50 a month into it. All right, so go into my formula up there. It says that A equals, and you can see that I have the payment sort of sitting out to the side. You can put that up top. Okay, so 50. You can also see up here where it has a bracket and then a parenthesis. It's hard on the computer to get 2 large parentheses. So I'm just going to use, this would be my bracket, but what I'm trying to do here is to actually write for you what you would type into your calculator. Um, so I would do 50, and then I would do a parenthesis, which is in place of that bracket, and then I would start another parenthesis, and inside that parenthesis, it's 1 plus your rate, and your rate here is 6.25%, so put it as a decimal, 0.0625, divided by 12, close your parenthesis, raise it, and if you notice that's in parentheses, raise it to the 12 times T. T is the number of years that she would have been contributing. It says she started at age 25 and she wants to retire at age 65, so that would be a total of 40 years, 65 minus 25, so multiply it times 40, close that parenthesis, and then it has a minus 1, close the parenthesis, all divided by, and then down here you need another parenthesis, 0.0625 your rate, divided by 12. This looks a little funky, and you think, most of you, again, if you were successful in the last section, putting all that in your calculator, you're going to be just as successful in this one. If you take this from left to right and type it in 50, parenthesis, 1 plus 0.0625 divided by 12, close parenthesis, raise it, so use your caret button or your y to the x, start another parenthesis, 12 times 40, close the parenthesis, get out of the exponent. Some calculators will leave you up there in that exponent. Get out of the exponent. Sometimes you have to hit your right arrow key or your down arrow key if your calculator won't get you out of the exponent. Minus 1. So it's just important that that minus 1 is down here and not up in the exponent. Close parenthesis, divided by, new parenthesis, 0.0625 divided by 12, close again. So again, if you have any trouble putting it in your calculator, I'd recommend doing the top, get your number, don't do any rounding, divided by, do the bottom, don't do any rounding there, don't do any rounding until the very end. Then take those two numbers, divide them, get your final answer. She would have in her account $106,595.63. Now, what you would hope is that along the way, yes, when she's 25, she may only have $50 to spare per month, but you would hope then, by 10 years later that she can start to increase, or even 5 years later, she can start to increase. And then with 10 years, increase some more so that, she's starting to increase those contributions, that she doesn't stay stagnant, because it should be, in years to come, she stays at that same job, that she would, have some hopefully some luxury of being able to increase that number. Not always, but sometimes you can do that. And those are some ways to, if you want to say, oh my gosh, I couldn't retire on $106,000, not many people can, you would say, okay, well, then let me, how do I get around that? You can increase your contribution here, of course. And then, certain companies also offer a pension. So this will be money in addition to your pension, okay? Part B says, well, how much money did you actually deposit into the IRA? So if you think about it, I'm going to do a nice throwback here to our Unit 1. She put in $50 per month, and she did that for 40 years. And in those 40 years, there was 12 months in each of those years. And I wrote all of those units out. You don't have to. You can just put in your calculator. But I wrote all those units out because now you can see, oh, my months are canceling out. My years are canceling out. The only unit I'm going to have left is money. And if I multiply straight across 50 times 40 times 12, you're going to find that she will have contributed $24,000 to this IRA. And so then if I want to figure out, so you don't have to show off that work, I should say. In your calculator, you can just, or I would definitely recommend that you write down, what did you do, 50 times 40 times 12, so that you can get partial credit in case you happen to mistype something in. Multiply that out, you get 24,000. So then in Part C, how much money did the IRA actually earn for her? Well, if the total amount in the IRA at the end of the 40 years was 106,000, a little over that, and she contributed 24,000, to figure out how much the IRA earned for her, just subtract those two numbers. So take that 106,595.63 and subtract the 24,000. And that's going to tell you that IRA earned for her $82,595.63. That'd be my final answer. Okay, and I will let you try example 2 because it's just like this one, and that gives you good practice to make sure that you are steady with that formula. Let's flip it on over then to feel free, it might be a good idea to pause the video and then we'll flip it on over to the next page. At the top of the next page here, you might say now, okay, well, I want to figure out now, how much money should I be putting away now so that I can have a certain amount of money in my future to either be my retirement or supplement the pension that I know that I have coming. So to figure that out, okay, it's a manipulation of the other formula, just like you saw in the previous video. So the payment is equal to that final amount that you know how much your final amount you want to have, times R over 12, divided by, and you can see that whole piece down at the bottom. Same thing before. I put these 12s automatically in, assuming we're going to just make monthly payments. All right, so, and again, all of the values stand for the same thing, so I'm not going to talk through that. In example 3 then, it says, suppose you're currently 35 and you want to start saving for your retirement. If your investment plans pays an APR of 6%, that's your interest rate, you want to have $1 million when you retire in 30 years. How much should you deposit monthly? So you're trying to figure out what should your monthly payment be. So I'm going to using that formula up there. The payment is equal to the final amount, which is $1 million, parentheses your rate, 0.06, divided by 12, close it, take all of that divided by, start 2 parentheses, 1 plus 0.06 divided by 12, close it, raise it to the 12 times 45, because we're going to have 12 times 45. 12 times 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . 45 . Actually, that won't be 45. There's a mistake on my solution key because that should be 30. That should be 30. 12 times 30, let me erase that. To the 12 times 30, close that parenthesis, minus 1. And now let me double check this in my calculator to make sure that I'm going to get what I have here on the solution key. I'm hoping that this number right here was just a typo on the solution key. I have 45 and it should be. Am I thinking about this right? Yeah, because you're 35 and you want to, and it says you want to retire in 30 years. So the time frame there is 30 years. So let's put this in. So I'm going to do million, parentheses, 0.06 divided by 12, close parentheses, divided by 2 parentheses, 1 plus 0.06 divided by 12, close it, raise it, parenthesis, 12 times 30, close it, minus 1, close it again, equals, yes, $995.51. I'll go in and I'll correct that. So that should be 12 times 30. All right. So essentially, well, okay, what does this mean now that you've kind of bumbled through that? Sorry about that. What this means then is that if you want to have $1 million in 30 years when you retire, then this person is going to need to put away almost $1,000, $995.51 every month in order to get that amount. So, it's a lofty goal. Example 4 uses a target value of 750,000, and that was actually a value that whenever I was searching online on Yahoo, that was one of their target values that they recommend for retirement was 750,000. So you can compare that one, and whenever you work through that problem, you'll see that the number is a lot smaller. It's a much more doable number in terms of it being more like a car payment, as opposed to this being closer to rent house payment. The value that you're going to get here in example 4 is more like a car payment, which if you get started, you can it can be made. These interest rates, though, it should be noted, are a little high for right now. It's hard to come by these nice interest rates too. So that's another, I guess, a little bit of a flaw in these particular problems. Hopefully things will turn around and get better. It should be noted, I'll move on from there. It should be noted that all the examples that I've looked at, I'm assuming that interest rate is staying consistent, but over a period of 30 years or 40 years, depending on how long you're investing your money, that interest rate's going to fluctuate, because just 8 or 10 years ago, these interest rates were a whole lot better than they are now, of course. So that for that reason, we want to look at, okay, well, what's my total return and annual return? These are the formulas for total and annual return, and what I'm going to do is go ahead and I'm going to flip to the next page and we'll work through them, and simultaneously as we work through them, I have a sentence below each one of them to explain what they mean. But you'll notice here in both of the formulas, they only involve an A and a P, and then annual return involves a T. So the values, your A and your P, A is your final amount and P is your original amount. So just be sure that P is your original amount and A is your, I'm going to put up there, final. A is that final amount, and this is original amount. All right, so let's flip it over then, and let's work through a couple, work through example 5, and like I said, just below that it says exactly what it means. So in example 5, it says you invest $3,000 in a Clearwater mutual fund. Over 4 years, your investment grows in value to $8,400. We want to know what's your total and annual return for that 4-year period. So my total return, you see your formula there, A minus P. So let me figure out what my A and my P are. So P is how much I put in. In this problem, it says that I invested $3,000, so that's got to be my P. And then it says that my investment over 4 years has grown to $8,400, so that's got to be my final amount. That's my A value. So now if I go to my formula, I'm going to start with a parenthesis, and then I'll start another parenthesis right away, and I'll have my A value, which is 8,400, minus my P value, 3,000. Close it. um, all divided by P, which is 3,000. And then you would close it again and then multiply times 100. Multiply times 100. So it should be that you start two parentheses, 8,400 minus 3,000. You're closing the top, divided by 3,000. And now you're closing that first one, times 100. You should get 180. That'd be 180%. So what that means, over 4 years, your investment has increased by 180% of its original amount. So, essentially, if you took 3,000 and multiplied it times 180%, so multiplied it times 1.8, and then added that back into your 3,000, you're going to get 8,400. So you're just trying to figure out, what's my gain from point A to point B, my initial to my ending value. It should be noted that these values could be negative because sometimes you invest your money and it doesn't make anything for you. You can end up losing money. So just know that, if you do get a negative, that what would happen here is that the word, instead of your investment increasing, your investment would decrease. All right, my annual return. So I start with a parenthesis, and then I go immediately to another parenthesis, my A, which is 8,400, divided by my P, 3,000. Close it, raise it, another parenthesis, 1 divided by T. I did this for 4 years, so 1/4. Close that parenthesis, minus 1. Be sure the minus 1's not in the exponent. Close that parenthesis, times 100. After you pop that in your calculator, and again, you should be able to put that in from left to right like that, you should get 29.4%. Will always be, I'm not sure if you had to round on that one or not, but if you end up having to do so, be sure, you just know on a test or a quiz, I'll tell you exactly how to round. This means that your investment increased because this value is positive. If it had been negative, we would just say decreased. Has increased by an average, that's the key word here, by an average of 29.4% each year. So it doesn't mean that it's increased by that much each year, but that's an average. Some years it had a better return, some years it had a worse return, but that's the average return each year. Okay, I'll let you try example 6, and then let's move down to the bottom and talk about some different types of investments. First type are stocks, and that's the one we're going to spend a lot more time talking about here in a few minutes. Some of you may actually already be invested in the stock market, so you're somewhat familiar with it, but essentially you're buying shares and ownership into a company, and as long as that company is doing well, stock prices, the value of your stock goes up. But once that company maybe has something happen to it negatively, then your value of your stock can dwindle. So bonds and cash investments are also other types of investments. Whenever you're trying to consider what kind of investment to, take part in, there are 3 things to take into account. And the first is the liquidity of it. How difficult is it for you to get to your money? So, for example, 2 types of investments that many of you might have. You might have a bank account, and you might own your own home. And so your bank account is very liquid. As long as you got stuff in there, you can go in and you can, draft from your account. Your property that you own, your house is could, if you wanted to unload it, it's not as liquid. You've got to find, you've got to get it on the market, and you've got to find the right buyer. So while it is still an investment for you, it's not as liquid. You can't readily get your hands on the money that's tied up in that house until you can find a buyer for the house. And so another thing to think about is risk. Is your investment at risk? 2 things to think about here. Maybe your bank account versus your stock versus being invested in the stock market. Your bank account has very little risk at all. Your stock market, though, a lot more risk, because once you're invested in that, then like I said a minute ago, anything that happens negatively impacting that company, stock prices are going to go down. That means the value of your number of shares in that stock goes down. And then ultimately the return. If and that's based on your risk. Usually what happens is if you're in a low risk situation, you're not going to have a high return. A lot of bank accounts have a very small interest rate that you are gaining interest on versus a stock market that's higher risk, but they typically do have a higher return. But that's not always the case, and that's why I put this little blurb down here at the bottom. Nobody, even if you talk to any kind of financial advisor, they're not going to be able to predict the future. So a lot of times, most of the time, what they're going to rely on are historical returns and trends to try to, point you in a direction of this is where the market has been heading. We don't know where it will go, but this is what we've seen in the past. All right. I'm going to flip it over to the next page. I am just going to do one part of example 7 and then mainly focus down here at the bottom. All right, so this is the idea of the historical trends that I was referring to just a minute ago. So these are the average returns for stocks: 6.3%, bonds 2%, cash 0.9%. So as you can see, there's more risk involved with stocks, and so obviously you're going to get a higher return versus cash here in this particular case, the overall that you see. In example 7 here, it says, well, suppose your great-great-grandmother invested $100 at the end of 1900 in each of those funds, stocks, bonds, and cash, assuming that her investments grew at the rates given above, so as the rates that I've shown up here. Approximately how much would each investment have been worth at the end of 2012? We use the compound interest formula to calculate that final amount, and we're just assuming that everything's going to be compounded once a year. So I'm just going to look at stocks, and then you can see from the solution key for the bonds and the cash. So for the stocks, I want to figure out the final amount that would have been in that account. I'm going to use my A formula. A equals P, how much you put in. So just put in $100, 1 plus my rate, and this is going back to the formula that you would have saw in 4B, your compound interest formula. 1 plus your rate, 0.063 for the stocks, divided by N, the number of times it's compounded. So it was compounded once per year, so N is 1. Raise it to the N, which is 1 times T, and you were doing this from 1900 to 2012, so that is 112 years. So if you pop that in the calculator, you should find that at the end of that 112 years, had great-great-grandmother done that, you would have potentially a little over $93,696.99. And so what it's worth then noting is that if you go through this problem and compare it to what would have been the payout for bonds and cash, you can compare, that this is that high risk and low risk type scenario. And it kind of goes back to that whole, that gamble, how sure and confident, but that's why no one ever has that crystal ball, and we try to rely on some historical data. All right, so lastly, let's explore some stocks. And what might be a good idea is to to pause the video and actually go through and read all of these pieces going around here, just so you can familiarize yourself with the vocabulary, and then come back to, and you may even want to try to answer as much as you can down there, and then come back to the video as I talk you through it. Excuse me. So in part A, it says, what is the symbol used for Microsoft? And that's usually found right up towards the top, and they'll usually have it listed all the way out, and then they will have just inside that is your the symbol, the ticker symbol that you'll see, like if you ever watch CNN or Headline News, you'll see that ticker going across your screen. So Microsoft is I don't need to use the parentheses there, I don't know why I did that, MSFT. That would be my symbol for Microsoft. So if you had shares in Microsoft and you wanted to follow it, then that would be what you'd be on the lookout for. Okay, so let's step it on up. In part B, it says, well, what was the price per share at the end of the day yesterday? Two ways to look at this. I'll first start with the easiest way, and that is right here in the middle. Prior day's close. That's your answer, right? Right. You don't have to do any work whatsoever. So it closed yesterday at $19.89. So another way to do it, though, is to look at what was the last price per share. and then look at the change, what kind of change that represents. So the last price per share was 1976. That represents a 13-cent decline from the previous day, because you notice up here the change represents since the prior day's close, so that represents a 13-cent drop. So if you want to figure out what happened yesterday, you got to do the opposite. You add the 0.13, and sure enough, if you add those two together, you're still going to get 1989. Okay, so whatever works for you, but I just thought I'd point that out to you. That obviously the prior day's close is the way to go. All right, so let's scoot on down. Part C says, based on the current price, what is the total value of the shares that have been traded so far today? So current price, that is this last price here. That's going to be your current price. And the total value of the shares that have been traded so far today. So we need to figure out, what vocabulary term represents the amount that's been traded so far today. And if you look at it, volume. You follow volume up. Volume represents the number of shares that have been traded today. So I'm going to take that 1976 and I'm going to use those units as best I can here. It's $19.76 per share. And then I'm going to multiply it times the number of shares that have been traded so far today, which would be 33,247,937 shares. And you see by me writing it like that, I'm just trying to, like I said before, what we learned in Unit 1 hasn't gone away too much. It can be a nice tool to use, what you're doing now. Now we can take that 1976, you can see, and multiply it times the 33,247 number, and you've got money left over, and we're talking about 655,979,235.10. So that would be the total value of how much has been traded so far today. Part D, what fraction of all of Microsoft shares have been traded so far today? So we know how much has been traded, but we want to know, okay, well, what fraction does this represent of the total amount? So we need to come up here and figure out, well, how many total shares does Microsoft have? And if you look at, trying to use different colors so that I can put that for the problem. Shares outstanding represents the total number of shares for the company. So we can see here then that Microsoft has 8,899 million shares. So in order to go down here in Part D to figure out what fraction of all of their shares have been traded, then I want to take the volume and divide it by the shares outstanding. Shares outstanding. So the volume is how much has been traded today. That's my 33 million number. And then I'm going to divide it by my shares outstanding. Now notice that that number there is represented in millions, so I need to take the number that you see there and multiply it times a million. So that's how I'm getting this number. squeeze this in here, 889972 with 4 zeros. As you'd be multiplying it by a million, which had 6 zeros, so you would take this decimal and move it 6 places to the right. Anyway, after you take that now and divide it, your calculator will give you 0.0037. That's the fraction that's been traded so far today. If you want to think of this as a percentage, you can multiply it times 100. And we're talking about 0.37%. So, given that Microsoft has, I'm trying to see how many does it have? Probably billion, thousand, million, over 8 billion, and only 33 million have been traded so far today, then that's why this figure is so low. Only 0.37% of all of their shares have even been traded. All right. And then lastly, we'll look into a situation where, many of you may have stocks and you say, okay, well, um, it it produces money for me. How does it do that? And that's what's called your dividend yield. And so what happens here, let's look at this example. So suppose you own 100 shares of Microsoft. Based on the current price and the dividend yield, what total dividends should you expect to receive this year? So what we want to take then is we want to figure out, well, how much money do we have? What's the value of the stock that we have? So if you have 100 shares, take those 100 shares and multiply it times the current price, which would be $19.76 per share. That way then shares cancel out, and you would have $1,976. That's the value of your stock. So you earn dividends on how much your stock is worth. So then if the dividend yield here is 2.61%, I'm going to take that 1976 and multiply it times 0.0261. Got to change it to a decimal. And that would be $51.57. You can choose that to be a payout, or what a lot of folks choose to do then is, hey, I could buy more stocks, get more, be more invested into the company, have now more than 100 shares. Because with that $51 at a price of almost $20 a share, you're going to be able to at least buy 2 more shares. And so, you might think, well, hey, that's just 2 more shares, but if you kept doing that each time there was, you got a dividend payout, then your amount of shares is going to accumulate considerably. So I definitely recommend you probably want to go through this stock piece again. It's usually one of the harder pieces. Because of that, in section 4C, and I believe it's at the review for sure, I've got an extra handout for you to try with just working on stocks, and the solution key is provided. Thanks.